That would be, in English, we would call that being facetious. So I'm calling it frog because if you create a program that says keylogger, your antivirus will eat it up. There is a third party or an open source library called PyInput, which has a keyboard library that will listen for keyboard events. And what does this mean when I see the little squiggly things and I open up a Python file in Visual Studio Code? Yeah, see, I have to reinstall all my. So in Visual Studio Code, that means that I haven't installed the PyInput library. So we'll use our standard pip install pynput library. And then it'll search through the, what is that place called? There's a central repository for all these things. In fact, PyPy, there it is. So PyPy is the central repository that people writing libraries for Py, this is where they're all stored. And then you can go in here, oh, see, this was updated, but it's still not up. That might be, now I can't remember if I've tried it since then. This may actually work in Kali Linux now. I can't remember if that's since I tried it or not.
What is the version? 3.15?
Yeah, they
3.13 doesn't work in Kali right now.
And it's working for me.
Yeah, Kali just
Do you
did
have
an
3
update.
point, you have 3.13? It could be just the way they integrate, because in Linux, as you know, they integrate Python with the whole operating system.
Mhm.
And it could be the combination of how Kali Linux implemented it versus Arch. Because Kali Linux is based on Debian. So that could be, but I think the 17th, I don't know if that's up to date or not, but that's something to try. And so this has all the different libraries in here. I try to, as much as I can remember, to put this into something where we're using a third-party library in case you need documentation, because all the documentation for this is attached to this. This gives you the basics. It does mouses and all kinds of things. And then it'll have where you can download files that have a release history. Sometimes they'll have something else, like right here, it has homepage. Well, that takes you to the GitHub repository, which they have the same, here we go, full documentation. It has its own read the docs.io thing. And so it has all kinds of things in here to tell you what's going on. So that's something, as you're using libraries, that's like one of the first places to look is with the source documentation that the people that wrote it created. All right, well, that is relevant because I'm not going to be here always to give you tutorials that work. This is object-oriented programming. This is a class. My class is the frog. One of my students turned this in and called it Kermit the Frog. You could call it Clifford the Big Red Dog. Just do not call it Keylogger. You can call this whatever you want. The class name doesn't matter. When you create a class, you have to use self in here. The init method automatically runs when we create a class. In other languages, that's called a constructor. We are constructing an object. And here's how we construct an object in Python. It's the simplest programming language to do OOP in. We are calling the frog class, and that creates an object which we assign to this reference, the frog. At this point, we're not using that reference for anything. But when we call it and create that object, the first thing it does, it goes up to here and it runs the init. The init has double underscores in front and back. That's called a dunder method, double underline, and that is a Python term for it. And usually those are secret methods that are part of the Python programming language. So let me pause for a second here. We're going to have a quick quiz. Every method, and they're called methods because a method is part of a class, has self in it. This makes this belong to the frog. The self makes this belong to the frog. Anywhere we see, well, I don't know if I have any variables that say self. No, I don't. We'll have variables later on that say self. But anything that has self belongs to the class. I don't have self on this because we only need it here. So as I mentioned earlier, when you have a class, this is how you create the class. This creates the class, sorry, this takes the class and uses it as a cookie cutter to create an object, which is stored in what's called a reference. When this is used to create an object, the init method runs automatically. When our init method runs, keyboard.listener, well, that's a class. Keyboard.listener, keyboard.listener, the .listener part is a class. So we're instantiating an object, which is another way to say it. We're creating a keyboard listener object that will sit in the back of our program listening for you to type stuff in. So it's running all the time. It has its own built-in threading function. So we've not done programs with threading yet, but what a thread is, let's bring this up here. It has to do with time slicing. Oh no, this is the right place. So we have this, I think these have like 12 cores on them, but look at all these things we're running. So each core can run a separate process or separate thread. Well, we can't build, well, you probably could if you had a supercomputer, but most computers do not have enough cores for, and each core can run 2 threads, so we can run 24 threads if we have a 12-core processor. And that's been that way since, I don't remember, it started in the Pentium or somewhere. You have 2 arithmetic logic units, and each of those can run a thread. So each core can run 2 threads. We can have, I think that's right. Anyway, we don't have enough to keep this stuff going. If we look underneath the frog process, look at all this stuff. These are threads, all just part of Studio Code. We don't have enough even to do this. I have no idea what pet.exe is. So we don't have near enough stuff. So what a computer operating system does is it does time slicing. So it gives 0.001 milliseconds to one thing, goes to the next, goes to the next. It's called a scheduler. And the same thing happens in Linux. Linux just had it way before Windows did. So it's a scheduler that schedules and takes care of, oh, this process needs some attention. Like right here, notice how the percent of CPU is going up. That means my Zoom is getting more attention than Windows Explorer. So it's getting more of the time sliced. The programs that we have run to this point have had a single thread. Unless we did Ping Plotter, which we did use threads. Did we do Ping Plotter? I think we did. Even if we didn't, that a thread is part of this. So we have our frog program running, plus we have the keyboard listening on a separate thread. So they both can operate independently. And the operating system takes care of the scheduling so that each one gets, you know, a little bit of CPU time. It's like with, it's just like Sean at work. They don't have enough, you know, police officers. They can't all be on duty all at the same time. So they schedule. So there's at least 1 or 2 officers on duty throughout the 24/7 period. I don't know if that's a good analogy or not.
That's pretty good.
But, you know, same thing as the hospital. They have to have nurses 24/7. So they schedule people to come in, and time slicing is, okay, Sean goes off duty, his replacement comes on duty. So that's time slicing. So the keyboard listener is running all by itself. And the with context handler manager, we've used, I don't know if we've used it before. Anyway, with means that we get a handle on the keyboard listener and we're using the keyboard listener and it's listening and it's listening. When we close the program, the with handler automatically cleans up the resources. We don't have to specifically clear them up. So this starts the thread. .join means that it's starting the thread. So now it's running in the background. This creates our object. This creates our thread where it's doing its own thing in the background. So we have 2 threads going on. Now, when we created the keyboard listener, there's all kinds of different things that we can listen for. We're listening for when you press the keyboard. And when we press the keyboard, this can be called a callback function, meaning when we press a keyboard, the keyboard listener is waiting for us to press a keyboard key. When we press a keyboard key, it says, oh, I should run this method. Every time you type a key, it runs that method. So this is telling the keyboard listener what to do when it hears something. So I type in a key, this receives the key press as an argument. Because that's part of the definition of how you use the process key press method. Well, it's not really called the process key press, I just called it that. But it's a method that's called when this happens, and it passes in the key as part of how this works. They program that, the people that program the Pi input. So I bring in the key, and all I'm doing is printing the key. If I press the escape key, it exits the program. So this is very simple to start with. And I discovered the only place that this can't listen is in a command prompt, which I found that interesting. You have to be careful when you're typing, otherwise you end up typing in your code, but you can type anywhere else that I've tried. And when you run it, it just shows nothing, which means if you can persuade somebody to run this program, you know, which is how do you persuade people to run your programs?
You send it as an attachment to something, and they
Yeah,
click
you
it,
say-
it doesn't open, they don't think about it.
You send them a
It's just running.
PDF that's an invoice that has it in there. You know,
Yeah,
I get
it's just
those.
running, they don't even know it's
Yeah.
running.
You redirect them to a website where this automatically loads. Because if you hadn't launched it yourself, is there any way to know it's running?
No.
There's no evidence at all. So if I close this and I go about my business and I go, oh, I want to go to my bank website, and then .pvbank.com is my bank, Platte Valley. And if I log in here, this is an encrypted communication, right? So if I type in my login and my password, will the keylogger catch that? Capture that?
Yes.
Yeah, the encryption between us and there doesn't matter because it's sitting here catching everything I've typed. And then at the end of this, we're going to have an email this to people, email it to us so that we can see what they've been doing. Now, this wouldn't be showing anything if I wasn't printing it. And I'm printing it to show that, yes, it is working. But look at there, www.pvbank.com, and I press the enter key to make it work. I'm not sure why I typed tab trying to autofill it, but then I messed it up and had to type it in. So in the background, you wouldn't even know this is running. You just have to persuade people to use it, which is social engineering. And there you go. So that was a lot, and somebody's chatting, and when I'm talking, I don't pay